Until the same bit arise, there will be no variation in a voltage. What do you mean by this? Now, I repeat again. See, the transition at the beginning of a bit interval, bit 1, and no transition at the beginning of the bit interval, bit zeros, or vice versa. This technique is known as a differential encoding. That means, very simple, I'll tell you. One is there, for example, assume for a 1 I kept on a low, until the next one, no I will be there. The continuous thing will be keep on going like that. Now you observe this particular example here, that is, you can observe here. So one, it started with a low voltage, am I right? 0, it doesn't change, and the next one it will change again, right? So once it has been changed to the high voltage, it will keep on moving with a high voltage until the next one. Until next one, that is after 3 zeros, 3 bit of a zeros, the next one is there, then it will come down again. Am I right? So then it will come down, then it will keep on moving, but next one is there, sequence, means coming bit is a 1, again it will rise. So that means that whenever a 1 bit is there, the voltage will change. Whenever it is a 0 bit, it will move normal. Either case it will be there. If you consider whenever 0 bit is there, it will change. Whenever 1 bit will be there, it will be in a common stage. Either ways, based on a different company's technology, this encoding technology will work. In this example, if 1 to 1, no change will be there. So this we'll call it as an NRZ inverted technique, which we are going to use. Coming to the next thing, that is biphase Manchester is there. Simple technique here how a Manchester will work. I'll tell you, we'll go with a simple example. You know that the technique I'll tell you. If 1 is there, Z, you take a Z symbol. If 1 is there, Z will be there. When 0 will be there, reverse Z will be there. That you keep in your mind always when you are doing an encoding. That is in a Manchester modulations, transition from high to low in the middle of the interval 1, and transition from low to high in the middle of the interval 0 will be there. Observe carefully, I repeat. If 1 is there, from high to low it will come down. When 0 is there, low to high it will move. That you have to keep in your mind. The best technique to keep remember this is very simple. If 1 is there, the Z will be there. If 0 is there, reverse Z will be there. That you keep a note. Observe carefully here the example how it is working. 1 is there, like a Z is there here, right? So you write, so what is there here? High to low. Whenever 0 is there, reverse Z, that is low to high. 1 is there, so high to low, that is Z. Again 0 is there, so that is reverse low. Again reverse low. Again reverse Z. So you have to fill up this particular gaps. Then coming 1 is there, again, so high to low. Again 1 is there, high to low. Again 0 is there, so reverse Z. In this way the encoding can be done using a Manchester. So these three techniques are a very important techniques which will be used in our encoding techniques. Coming to the next technique, that is the 4b bar 5b encoding. What is this 4b bar 5 encoding? In same it works like in a Manchester encoding. In Manchester encoding scheme, there is a transition after every bit. After 1 bit, there will be a transition will be there. It means that we must have a locks with double the speed send same amount of data as in NRZ encoding. In other words, we may say that only 50% of the data is been sent, remaining we have to fill up. So this performance factor can be significantly improved if we use a better encoding scheme. So what a better encoding scheme which you can use here? This scheme may have a transition after fixed number of bits instead of every other bit. Instead of sending every one bit, if we send a set of bits if we have a transition after every 4 bits, if every 4 bits there is a transition, means a gap is there, then it will be good, rather than every single bit a gap is there. What actually gap, you will get a doubt, am I right? You see here the Manchester, what I am filling up here. Now observe here, so this is there here, the 1 is there here, and a 0 is there, right? Again 0 is there, low to high will be there, this is a gap here, right? So this a clock should maintain this particular gap here. Coming to here, this is a gap which it should maintain. So this is a one very important thing. Each and every bit, it will take 50% of your encoding things, and only 50% data will be sent. But every 4 bits if you send, then it will be good. How we can send every 4 bits? Every 4 bits I will identify every 4 bits. How this will work? This scheme is known as 4b by 5b. So here we convert 4 bits to 5 bits, ensuring at least one transition in them. The basic idea here is that 5-bit code selected must have one leading 0, no more than 2 trailing zeros. That you have to keep in your mind always. This is very important thing. That is, one leading 0 should be there. Always one leading 0 should be there. No more than 2 trailing zeros will be there. No more than 2 trailing zeros will be there. Best example, come here, I will tell you. You see this particular concept here. This is a 4-bit data if you assume. Now assume here actually 4 zeros are there. 4 zeros, one leading 0 should be there always. So because of that, it will be converted to 4 ones and a 0. And observe the next thing, 3 trailing zeros are there here. So this 3 cannot be there, only 2 trailing zeros can be there. So what we will do? We will put 1 here in between 3 trailing zeros. That is 0 1 0 0 1. Now come over here, you can see 0 0 1 0 is there. Trailing 0 0 is there, and 1 0 is there. When leading 1 0 should be there. So 1 0, and here 2 zeros, whatever is there, it will be breaked again. So because of that, means if I put another 0 here, it will become a 3 zeros. So because of that, 1 will be there. Like this encoding system will be done, which you can take into the consideration. That is, you have to always, this is a fixed coding thing will be there, which you have to know how to convert this from 4-bit data to the 5-bit coding here. So 0 to 111, that coding thing is there, which you can convert. That is 0 to 16, whatever is there, you can convert to the 5 bits with a leading 1. That leading 1 will represent in a encoding. So this is called as a 4b bar 5b encoding. This encoding techniques will plays a very much important role to move from one system to the another system. Thank you very much today for this particular session. In the next session, we'll move with the framing techniques. There are different types of framings, how a framing technique will be done, and how things will be taken into the frames and all, and how a stuffing will be done, bit stuffing and a byte stuffing. That and all we'll discuss in a coming next class. Thank you very much.